All right, so I'm going to pull up the questions from the notes and video that may have been a little incomplete just to kind of clarify anything here. So we get to this point with using some of the, looks like we use one of the identities here. And so to get them down to where our angle is both just theta. And so what you want to do from here, and by the way, no, you won't be given the graphs. Those are just kind of a little bonus to kind of give you more of a visual of what's going on. If you have a graphing calculator and you're familiar with using it, you're more than welcome to kind of use that to kind of help you visualize this, but it will not be provided. So on this particular example, what we want to do is basically set it equal to 0. And so what I'm going to do first here is kind of clean up the left side right here. I can go ahead. I've got that -1 and that +3. Let me see if my pen will work. Okay, here we go. So I'm going to go ahead and combine that. So then I'm going to have 2 cosine of theta squared plus 2 equals 5 of cosine of theta. And so what I'm going to do here is, like I said, I want to set this equal to 0. So what I'm going to do is I'm going to subtract 5 cosine of theta from both sides. And I'm going to kind of squeeze it in right here between the cosine squared and the +2. So -5 cosine of theta. And so what we end up with here is we have the 2 cosine of theta squared -5 cosine of theta, and then we do have that +2 there. Okay, so what we can do here, in the video, I'm pretty sure they show you substitution, which is fine. Substitution is fine. I just go ahead and just factor it the way it is. But if you wanted to, you could replace the cosines with like 2u squared -5u plus 2, and you could factor that if you wanted to, and then you replace the u back with the cosines. But I'm just going to leave it how it is and go ahead and factor this. So basically, I know that I'm basically going to unfoil this, right? So I'm going to break this into 2 binomials. And so this is the first 2 terms being multiplied together. That's what gives me this 2 cosine of theta squared. Oops. So what I am going to do here is I'm going to break that into 2 cosine of theta times just a cosine of theta. And so see, if you were to multiply those 2 together right there, that's where this first value comes from right here. Then the inner and the outer are what create that -5 cosine of theta. And then the last 2 getting multiplied together gives me the +2. So I got to kind of figure out how am I going to get the +2, but then the outer and the inner add up to -5, right? And so it's going to be they're both going to be minus. So I'm going to have to put the -2 here and a -1 here. And you can see that -1 times -2 is +2. And then the inner and the outer, you get -1 cosine, -4 cosines. And when you add that together, that's where you get that middle term from. So now I am ready to go ahead and solve those. And so using the 0 product principle, because these are getting multiplied together, if either one of those were to equal 0, the whole thing will equal 0. So I'll take this first one right here. So 2 cosine of theta -1, set that equal to 0. And when you solve that, let's see, we'll add 1 to both sides. And then we will go ahead and divide by 2. And so let's see, divide by 2. So we end up with cosine of theta equals 1/2. And then I'll, if you were to look on your unit circle, so cosine is equal to 1/2. Let's see, that would be up here at pi over 3. And let me look at the parameters just to make sure. Okay, so the parameters, yes. And so we're going to want radians for the most part. I don't think we'll probably do degrees too often, but between 0 and 2 pi. And so then the other one would be down here. And so that would be at 5 pi over 3. And so those are the two spots where cosine of theta would equal 1/2. And so those are actually going to be our only answers, because if you look at the other one, so if you take cosine of theta, minus 2, and try to set that equal to 0 and solve. So we would add 2 to both sides, but then that's not possible. That ratio right there is not within my possible domain right there. So for my possible values of theta right there, you'll never get a ratio above 1. So that's not even possible. You could try, if you put it in the calculator, it's going to give you error, so that won't work. So these are the only two answers we're looking for on this particular example. And let's see, we'll go back up, and if you look at the picture, that probably seems about right there. Okay, let's look at the next one. So the next one, let's see. So we went ahead, let's see what we do here. So they used, okay, some of these identities, and then went ahead and got it down to this point right here, but then it wasn't factorable, right? And then there's the substitution where you can kind of think about it. And so if you remember the quadratic formula, so negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So that's what we got going on here. So you were asked to kind of finish this in the video. And so what we want to do here, now these are going to be decimal answers. I know that was another question, when do we use decimals? Typically, if you don't see the value, if you can't find the value on the unit circle, that's when we're going to do decimals. So here we are. So we do need to finish off this algebra here. So let's see, we're going to have, working with sine now. So let's see, sine of x equals 1 plus or minus the square root. So let's see, this will multiply together to give me, basically it's going to turn into a plus 12. So I'm going to end up with the square root of 13 on top, and then we're all divided by 6. And so then I do need to look at this in both perspectives. I need to look at it as a plus and look at it as a potential minus. And then I do need to be careful about my parameters, right? So my parameters are between 0 and 2 pi. So that is going to make things a little tricky here. Give myself plenty of space. So I need to look at this as sine of x is equal to 1 plus the square root of 13 over 6. And then what I'm going to do is, once I figure out that value, I'm going to have to take the sine inverse of that. And then same thing with sine of x equals 1 minus the square root of 13 over 6. So I'm going to have to grab my calculator. Okay, so here's my calculator, and so I'm going to go ahead and make sure I'm on, oh, yeah, I want to be on radians. So there we go. And so then I need to figure out, I mean, I could type that whole thing in there. It's not that big of a deal, but you have to be careful on how you input it on your calculator. If I want to type that whole thing in there, so I'm going to do the sine inverse of that. Now I have to be careful if I put this in my calculator, the whole thing, I need to put the numerator in parentheses to indicate that that whole thing is going to get divided by 6. So I know I have an open parentheses, but I got to open up a new set right here. So I open up parentheses 1 plus the square root of 13, and then I'm going to have to close. And so depending on what kind of calculator you're working with, this is kind of an older one. Some of the newer ones are a little bit more user-friendly on how to type some of this stuff in. But here we go. So that's my numerator, and then I have to divide it by 6. You could have also just put this in the calculator and got a decimal answer and then just type it into like 4 or 5 decimal places, that would be fine too. But I'm doing this all at once. So I'm doing the sine inverse, and let's see, what do I get? So I got 0.875. So let's just go with 0.875. So that's what my angle would equal. 0.875. And so if we were to look at this on the unit circle, now we're talking about sine, so we're talking about the y value. If you're kind of looking at a unit circle, it would probably be about, the angle would be about like right here, because up here, this is where 1 is at, right? So I'm at 0.87, which would be about right here, okay? Now, there's going to be another angle that the calculator doesn't tell you about, which is going to be this one right here. It's going to be this one right here, which is, it should be actually symmetrical. It's not perfect, but it should be a reflection across this y-axis right here, because that height is also going to be 0.875. That's what those heights are. That's what that's telling us right there. Okay, so then, or wait, I'm sorry. I'm actually giving you bad information. Let me put this in the calculator real quick, because I'm thinking of something different, but it's actually going to be probably pretty close. I'm thinking of what that value is right there. So let me go ahead and type that in real quick, because I was actually, that's actually the angle size. So that's actually not going to be perfectly correct, what I just said. So I apologize. Let me put that in the calculator so we can get a feel for what that y length is. Okay, so let's see. Square root of, oops, I'm going to put the plus. The square root of 13. And then we'll go ahead and divide that by 6. Okay, so that's going to tell me what the ratio is. So it wasn't far off. That's actually what that green line is that I was trying to indicate. So it was like, we'll just call it 0.77. And so see, that's the distance of this side right here. And so the angle in radians is the 0.875. And so what I was trying to indicate over here, it is over here also. And so the height of that side right there, the y value, it's going to be 0.77 also. So that's the height of it. Now, the way that I am going to figure out what that angle is in radians, so see the 0.875 is this angle right here. But I also want to figure out the angle going to right here, right? Well, if I know that this angle right here is 0.875, well then so is this angle right here, right? So is that angle right there, that angle right there with the x-axis and my other terminal side that I'm coming up with right there, that angle right there is also going to be 0.875. So if I want to figure out the angle from starting at my initial side right here on the x-axis and rotating around to right here, well, a half a rotation is pi. A half of a rotation would be pi. And so if I were to subtract off the 0.875, then that would tell me what this angle is right here. From here to here, it's going all the way around to that second angle that I was indicating right here. So that's what I'm going to have to do to figure out my other angle, is I'm going to have to take pi, and I'm going to have to subtract off 0.875. So let me go ahead and do that. And so let's see, I got to take pi and then subtract off 0.875. And so that's going to give us let's round that to 2.267. So 2.267. And so that would be the other angle in radians that would also give me that that ratio for that y value. And I can prove it to you real quick. So if I were to take sine, and I'm going to plug that number in right there, 2.26, we'll round it up to a 7, right? I'm going to get really close to that 0.767591 I have up here, because that's telling me the ratio right there. So I just want to show that to you. So see, look at that. See, I mean, it's not quite perfect because it's around, I put a rounded number in there, but that's what that's telling us. So sine of this angle will tell me what that length of y is. Really, it tells me the ratio of y divided by r. But you can kind of simplify it into what the y value is for that angle where it terminates right there. Okay, and then we're basically going to do the same thing over here. And what I'll do, maybe it'll make a little bit more sense. I am going to go ahead and figure out what this is, and then we can plug it in. So let me clear this out. And so let's see, I'm going to have parentheses 1. This time it's minus the square root of 13. And then let's see, we're going to divide it by 6. And so we get 0.3, we'll just do 0.399. 0.399. Okay, and so now what I'm going to have to do is in my calculator, I'm going to have to take the sine inverse of 0.399, and that will give me what my angle is right there. Now, once again, just to kind of draw a picture to kind of help illustrate this. Let's see. So what's going on here? Okay, so what's going on here is that right there. So if you look at a unit circle, the distance to the edge is always, you know, the radius is always 1, right? And so we're talking about sine. So the y value right now, right here, the y value would be 0, 1, 0, -1, right? Well, we're looking for where is the y value going to be 0.399, basically 0.4, right? And so this would be about positive 0.5, right? That'd be about positive 0.5. So if I were to go around this, it'd probably be about right about right here, right? That right there, that y distance right there, that y distance right there would be about 0.399. And then I'd also have that same height of y over here. If I were to go over here, this distance right here is probably about the same thing, about 0.399, right? So yeah, the calculator is going to do most of the work for us. So let's see, we're going to go ahead and take the sine inverse of 0.399, and so it gives me the first one. So it's not always going to give you or it's not going to give you both of them. It's only going to give you certain quadrants, and for sine the calculator only tells us about quadrant 1 and 4. So I know my first one's going to be x equals about we can round that to 0.410. So 0.410. So that's what that angle is. That's the rotation angle right there. And then in radians. And so now we want to know this one right here, right? Well, remember, a full or a half a rotation would be pi, right? And so this angle that's created with the x-axis is the same angle that's created with the x-axis of my first angle. So to figure out the second angle here, we're going to take pi, and we are going to subtract 0.410, and then that will give me my other answer. So this is one of my answers, and then we'll put the other one in the calculator. And let's see, so pi minus 0.410. And so we're going to get about, we can round that, let's see, to 2.732. 2.732. And so then that would be my other one. So there are 4 correct answers to this one, and I have them all boxed here. And so I know it's a lot, but hopefully that helps clarify some of that. Let me see. I know I have a couple more I wanted to go over, but I might... What I'm going to do, this video is about to get to 20 minutes. I don't like to go over too long. So I'm going to go ahead and stop this and then create a second video for the other questions.